Otherwise, I socialize. How is it? He's like, oh yeah, I'll do it. I don't really care. For now, whenever I need help, I go. Whenever I don't need help, so I check it out.
Okay, so let's start. So apologies for being a little late there. I edited the wrong set of slides. So I had the old set of slides with some new notes in it, and then the new ones were nowhere near what they were supposed to be. So I had to quickly reformat things. Okay, so just a couple of announcements. Oh, that's not 4 weeks from today. That's 8 weeks from today. Okay, so the final exam schedule is out, the tentative one. And this course is scheduled for December 9th. And so 8 weeks from today. Okay. So 5:30. Or not 5:30, I think it's 3:30. I think that's wrong too. I think I was thinking the end of time. So, okay. Anyway, the key thing about that is you should go online, check the exam schedule, and make sure that you don't have any conflicts. And if there are conflicts, report them to whoever it is you're supposed to report them to. Okay. A2 will be posted later today by 5 o'clock. So what you're going to do in assignment number 2 is you're going to build a DNS resolver client. So could people just quiet down a bit, please? Thank you. So you're going to build a DNS resolver client. So essentially what you have to do is you will be given, well, how the program will work is that you will type the name of the program in. This is in Java. You will give the root name server, which may not mean anything to you right at the moment, but it will later. You'll give the root name server, and you'll give the name of something that you want to look up. And then it has to go and do what happens in the background whenever you look up a name. Okay, so that's what the assignment is. It's due November 4th. The repos are not available yet, and that is deliberate. There's a lot of stuff that you need to understand, and I don't want to encourage you to write code too soon. By a lot of stuff, I mean there's a lot of different scenarios you have to think about. None of them are particularly complicated, but you just have to sort of enumerate them. So you need to go through the exercise of enumerating what some of the scenarios are. And to help you with that, when this becomes available, you will find that there is a directory in the assignment that has a bunch of traces in it. These are traces with a program similar to, for a solved version of the assignment, so that they're traces from that program. And what you can do is you can run those in Wireshark, and you can get a sense of, okay, here's the queries that need to be done, here's the types of responses I'm going to get back, and then you can try and figure out, okay, based on those responses, what's the next thing you're supposed to do. And of course, there's not, it's just not a detective exercise in trying to figure out what you're supposed to do based on these traces. There is, in fact, an RFC that goes along with this to define what you're supposed to do and how you're supposed to proceed. So you have to read a little bit about that. And so this week in tutorials, what we'll do is we'll focus on starting to get you up to speed on that. So one of the things that has to happen is DNS uses UDP. We'll talk about that later today. But UDP is a connectionless-based service, so it's just sort of like sending postcards and you're getting answers back. So you interact with that in a little different way than you did for assignment number 1. So this week's tutorial will focus on getting you up to speed on that. Also, you have to write binary data and read binary data. It turns out that DNS, a number of the fields in it are binary, so you're going to have to figure out how do you do that in Java if you haven't ever read or written binary stuff before. So we'll introduce a little bit of that. And then also how to start interpreting some of those traces and how to get going on that. Okay? Okay, so any questions about that? Yep.
Why is it 4 weeks from today, an exam?
Because I made a mistake. It's 8 weeks, yes. Maybe I'm just wishing the term were over. I don't know, something like that. I think it was because I was thinking about when the assignment was due, and I was thinking, okay, I think the assignment's due like in 4 weeks. Oh, no, it's 3 weeks, and I probably just wrote that down. Okay, so with respect to reading, what we have is the transport services, which are in section 2.1.4, along with DNS in 2.5 later in that section. And so that's sort of the types of readings you should be doing. And today I want to finish off network address translation stuff and hopefully get started on domain name services. Okay. So we've done a few of the things that are up there already. So I just want to finish off this, wrap up a few loose ends. And here's how I want to sort of remind you about what's going on. Okay, so we've got the famous picture up there. I've got my natting router. We've got some machines on a non-routable IP address. So one of the questions might be, well, if I have a machine that's on the inside of the router's area there, so on the non-routable addresses, what if someone wants to connect to me? We saw already that what happened when we want to make a connection. What happens is it goes out through the router rewrites things, and then off it goes, and then it uses this entry in a table to figure out how to get the data back. But if you're, say, a web browser and you're just sort of sitting there, what do you have to do there? Okay, so that's a little bit different. So it's not actually, so we're not going to be able to change the router. Right? So with respect to how it behaves, so what do we do instead, or what do we have to do? Well, what we essentially have to do is we have to pre-populate the router with these translation rules that we want. So we would have to, if you want an incoming packet, for example, to go to port 80 on a particular machine, you might say, okay, well, if you go to 142.18.34.67, so we should draw a picture of this. So we've got our router, and its address is 142.34.67, and then we have our 172 guy down over here. Not going to write that out completely. So what we do is we pre-populate this and we put a rule that says if you're coming from 142.18, no, sorry, if you're going to 142.18.34.67 on port 8000, then what I want you to do is I want to reroute you to that guy and just rewrite that with 172 on this side. Okay? And I also reroute this particular address as well. Okay? Or sorry, port number as well, I should say. So we rewrite that to 80. And so now what happens here is the packet will show up here, and it will have the destination address, the source address of, it doesn't say. Okay, well, we'd have our source address, port number for the source, And then we would now have 142, 172, 16.2.187, and 80, okay? And so it would come in, it would connect to that. There's some packets that go back and forth, but the basic gist of this would be is that when it decides that it's going to send back to here, right, it's going to come back here and it's going to find a rule that was added. So we've got one rule that says, you know, any host ID, any port, if it's destined for 142.18.3467.8000, rewrite it like this. And at the same time that it does that rewriting, it has to add another entry in there, because what it wants to do is it wants to say, okay, now I have a new path, right? So let's say this is host A and port 21. So now what you'll have in here is you'll have A21, okay, so that's, and then you'll have the rule to go to 172, 16.2.187, 80. And so now what happens is when we come here, we'll come through this way, it'll come back through, and it'll say it's coming from 172.16.2.187, it's coming from 80. I don't have to do anything here, right? Because my source address and port number are in fact what they need to be, so I just let those through, and then I rewrite this to 8,000 or something like that, whatever I want, or it has to be 8,000, I should say. And then on the way back, we have this other rule that says, okay, it came from A21, or A, port 21, I want to go to 172.16.2.187.80, okay? And it may have to rewrite this if you know, you had another machine or something like that already using some of that. Yep.
What does the 821 represent?
Sorry?
What does an A?
Oh, the IP address of the machine out there someplace. I didn't want to write some long address up. So the basic thing here is you sort of pre-populate it, you get it going, and when you have a connection coming in, you have to record a rule. So remember what we did before is on our way out, we added a rule. And this is on the way in, we're going to add a rule as well. And then this is sort of telling us how to sort of complete the rule. And if you can't find a rule, then you don't do anything. So this is sort of what UPnP is all about, Universal Plug and Play. This is a protocol that you can run internally on your network. And it essentially requests the, excuse me, it requests that the router start those, or open up a particular port. So that's what this is referred to as when you do this. You're saying, okay, I'm opening up a particular port, and here's where I want it to go to. So it's saying, here, add a rule for that. Okay, okay, any questions? Yep.
So is this done automatically, or
Sorry?
is this done automatically, or does it really?
Oh, okay, yes. So it depends upon, the question was, is this done automatically, or does an administrator have to do this? So no, this is something that there's sort of, the two strategies are, in fact, like you said, one is an administrator has to go and do it, so by default there's nothing there. So that means by default nothing gets through. Or, so an administrator has to go in and do it, right? So you might sort of say, okay, here's where I want it to go. And usually you can actually even be more restrictive than that. You can actually pre-populate it and saying it has to be coming from a particular host on a particular port, and then it's allowed through. And if it's not, so in other words, you can get rid of the any host, any port part as well if you want, and just sort of even be more restrictive. So an administrator does that, or your program does it by running UPnP on it and requesting that the router do it. Not something that I necessarily recommend, given that who knows what could happen if any machine gets compromised or anything like that. It could ask for ports to suddenly be opened up, and now anyone from the outside world who sort of has tried to infect your machine might be able to get in there, get into the inside. Okay, any questions? Yep. Oh.
Considering that NAT was created to solve, to do something about the running out of IP addresses problem, how reasonable is it to also be using it as a firewall, as you just described?
I'm not using it, I'm only using it as a firewall in the sense that I'm putting in a specific rule. So it's really a question about, I mean, I'm going to talk about firewalls in a moment, but you also have to take a slightly different perspective on this and say, okay, so what's the issue? The issue is that we need translation rules in here. And so how do those rules get in there? And if you're willing to accept that it's okay for someone to enter those manually, then it kind of also has this firewall feature to it as well. Right? Natting nothing about natting says that it's only one way. Right? All it is a set of rules that tell you how to translate external addresses to internal addresses. And really what we're sort of talking about is how do those rules get established? Those rules are, in some sense, just policy. They don't have, the weight of any organization behind them or anything like that. So it's just a matter of saying, okay, well, what makes the most sense? So you could say, well, all rules have to be entered manually. In which case, that would mean that every time you had an outgoing connection, you'd have to go in and enter the rule before you were allowed to before any traffic could go out. And so there's kind of an observation made that, most of the time when you have something natting, the issue really is that the traffic is going in this direction, it's going out. Is there a nice way to add rules? And so, well, yeah, we can just notice that the traffic is going out and add the rule. Okay? But there's nothing sort of in the definition of NAT that says that that's the way it has to be.
My question is directed at how you don't recommend UPnP because something could be getting in, and yeah, I was just questioning.
Oh no.
Using that as a protection mechanism to not use UPnP.
No, it's just the idea is just that we know that the way that most routers are set up nowadays is that traffic going out is allowed, and they put in rules. And there are no rules for traffic coming in. So you're not allowed to, there's for traffic to just arbitrary hosts. Only on established connections are there rules. So the existence of the rule is a result of traffic going out. And so the question sort of becomes, well, who should be allowed to put rules for coming in? Who do you trust? Right? Do you trust an administrator, or do you trust a program? And so if you're confident that none of the machines on this side of your network could ever be compromised, then go ahead and do it. If on the other hand, you have no idea how trustworthy those are, maybe it's your friend from down the street who likes to frequent internet cafes and stuff like that, and they just happen to be hooking up to your network while they're visiting you, maybe you have a different thought on that, how much you trust it. So, okay, so let's try some. I have some Socrative questions set up for this, so let's give this a try, if I can find them. Come on. Come on. There we go. Whoops. Are the pictures visible? Pardon? It's asking, oh, is it asking you to give a name? Yeah. Okay, just a sec, I'll start it over again. As soon as I find the mouse here. Oh, I see what it did.
Yeah, oh, I got it right. How's that like? No, that's tough, I see.
I'll ask her. It sounds good. No, I feel like I should.
Okay, so I'm going to stop that in a moment. So yes, so I just stopped it. So yes, so the correct answer is D, so the majority of you are getting that right. So let's go on to the next question. If I can find my mouse again. How many questions are there? Oh.
I actually like don't have like grades. Because it's fun. It just makes the probably really confusing that.
It's not right.
It was naturally because of that, right? I got
The right answer is A? It says it's not A. Well, it is A. Sorry?
I want the question.
I'm not sure if you guys are getting, I think you're getting feedback, but the answer, the right answer is 189, 26, 51, 23. So So answer A is the correct answer. So the key thing here is, I don't know what, I think it reported something else. Probably just meant that I had a typo in it. So the key thing here, though, is that you do not send, even though the packet is going to 189, you do not address the packet to 142, to the 142 1834.67. That's where it appears to be coming from if you're at 189, okay? So if you're at the 189, 2651.23, it will appear to be coming from 142.1834.67, but the actual sender will be sending it to 189. And when it, okay?
Well, ask a question about this again. About EPNP or picture. Let's say 187 sends it to 51 outside to 5123. So previously we would still send it to 5123. The router would overwrite the source address from 187 to itself.
192 to 142, yeah. 192, 168 or whatever. Oh, I'm reading off of this one up there.
Yeah, so it will replace the destination address with,
The source address.
sorry, yeah, source address. Replace it with its own instead of the original one.
Yes.
But when we have UPnP, we don't do that.
Well,
We still do that, but
no, remember, you don't have, the replacement is done here, not here.
yeah.
Right, so you still do the replacement, except that it's done here. This guy doesn't, so the destination address is never replaced. It's only, from this guy's perspective, it's only the source address. So on the way out, it's the source address that's getting changed.
So when the rule is, so I just don't understand when the rule is set up. So is the rule set up when 187 sends the request, the router gets that packet, starts rewriting the header? Is that when the rule?
No, the rule comes into effect on the
way back.
when it's PNP, or when you have something that's going from the outside wanting to connect to the inside. The rule is entered. So you have a partial rule that says where you need to how to translate it to here, and then you add a more explicit rule as it goes through. Just like when you, for example, when we send a packet from, so if we start out from here and we send a packet on the way out, right, what's going to happen is that when it hits here, it's going to say, oh, I don't have any rule for this, I need to add something. And so it'll add it. In the other scenario, we're coming in this way initially for the first time, right? And so this way here says, okay, well, I need to be able to get it back to where it's going. And I could have rewritten I could have rewritten this, or any of these things might have to be rewritten, so I have to add the rule in at that time to know where it's going.
So UPnP only matters when you have outside connection?
Yes, UPnP only matters for outside stuff coming in, right? It's a way of saying, it's a way for a computer with some applications running on it to say, I want to provide a service to the outside world. You're going to have to allow them to come through. And here's the rule that you need to do that. Okay, so let's. Okay, I only had two. Okay, so I only have the two questions there. Okay, so we're done that. Get the right set of notes up today. Okay. That. Okay. So one other thing. So everything that we've seen so far as natting is concerned in that is relatively benign. One, we've made some arguments about why it isn't that great, but there's actually a real killer one for some of this stuff, okay? So I'm going to give you an example here of a problem. And this is one, the only way that you can solve it, or you have to sort of go all the way up to the application layer to solve this. So far we've just looked at the network and the transport layer as far as NATing is concerned. And so here's a problem where, in fact, you have to even go into the application layer and you have to understand something about the application level protocol for it to even work. Okay? So let me draw out that scenario. This isn't the only protocol that's like this, but this is the easiest one. Okay. Okay. So there's a protocol called FTP, called File Transfer Protocol. And what you do is you essentially establish a connection, just like a telnet session or an SS, or if you're not familiar with telnet, it's like an SSH connection to a server. So you make the connection here. So you make the connection, and then what you do is you type commands to it. Okay. And you can do things like give me a list of the files that are there, get me a file from that location, send me a file to that other location. Well, it turns out that the way that this is structured is that, unlike something like HTTP, or mail for that matter, all that you ever do, this is referred to as a control connection, and all you ever do on this control connection is send commands and get indications of whether the command was successful or not. You never actually get any of the results of the command. Okay? So if you want to, for example, transfer a file, what has to happen is that you'd go something like, you'd say get, and you'd give the file name. So that's what you would sort of type at the highest level. And there's a lot of stuff that happens underneath, but one of the things that happens underneath is that since they don't really know how big this file is going to be and stuff like that, they're going to say, okay, well, the way we're going to do that is we're going to establish a connection back this way if we're doing a get. Right? So the direction of the connection is going from the server back to the client. And so it has to do a connect. It has to do an open to do that. So this guy goes here and connects here. Now, your first question, well, not maybe not, but one of your first questions should be, well, where does it connect to? Right? Because this guy's going to send a file, this little program. So what actually happens is this guy sends to it, oh, by the way, so since there's just one program that's doing this, by the way, I've already got a program, or part of me is already listening for you to send data. Okay? So what this guy will have done is it'll have it'll create a socket. And then it will tell the other guy, and it's going to go open. It's going to open that socket, and when it's done, and then it'll start, and then once it's open, it'll read it until it gets to the end of file, and it'll write the contents out while it's doing that. Okay? So the key thing here is, well, how does it know where to open it? So what happens when you create a socket, or one of the things that happens when you create a socket is you have to have a port number. Okay? So just like when you connect to an HTTP server, and you go, what port do you connect on? Port 80, right? So why port 80? You know, why not some other port other than convention? Well, for that to actually sort of work on the HTTP server side, the HTTP program starts up, and what it does is it says, open me port 80. Okay. And then it listens for connections. Same thing here, except you're not quite so specific about which port you want. You say any port will do. Okay. So create me a socket, open it on any port, and now you have to tell the other side, okay, since I want you to connect to this, I have to tell you what it is. So along with the get command here, you also have to send another command, which I cannot remember off the top of my head, that on the wire, but basically says connect to me, whatever my IP address is, on port 3000, let's say. So it goes and it does that. But think about what I just said. Right? This is an application level protocol. If we look at our protocol stack, that means that the routers and things like that aren't supposed to be looking at that layer, right? Because they only look at the network layer, and if we have routing, we look at the transport layer as well. But this is data that's sent in the application layer. And so you send connect to me on 172.16.2.34. Well, what are you doing? You're telling it, what's my IP? How, when you do this, what are you going to do? Say, well, what's my IP address? Well, it's whatever my IP address is. And if I'm on this side of the router, of a NATing router, it's a non-routable IP address. Right? So I don't know that I'm behind a NATing router. Okay. So I send this here, and I also have to send the port along as well. So I send those two things along. This guy goes here. What's he going to do? He's going to go connect to 172.16.2.34 on port 3000. And what's going to happen? Well, it'll do that. It'll start the packet to do the connection will get out. It'll hit that first router. That first router will say 172.16.2.34 is a non-routable address. I'm not going to route it, and it will drop it. So nothing ever gets through. So if you want that to actually work, then what you have to do is the application layer. So someplace here when you send this 172.16.2.34, that has to be replaced with whatever this address is here. Okay. So you have to replace that with that. And also because you have a port number involved, there's also the potential that, well, somebody else could already be using port 3000 to that machine. So I have to change that as well, potentially change that as well. So this has to be rewritten at the application level to say what this IP address is at the very least, along with that port number. So now the router has to actually be looking up into the application layer to get that to work. So there's a problem, and there's another argument that says, okay, one of the things that you can't do then is you can't write applications that if you're on this side of the firewall, or not the firewall, sorry, on the router, if you're on the inside of the router, it means that you can't write applications where you tell the outside world what your IP address is and expect them to contact you. You're not going to be able to do that. So you can get away with it, excuse me, with FTP and a few other protocols because they're very popular. And so manufacturers are willing to sort of invest the resources in now also inspecting the commands that are being sent across this line and rewriting them as appropriate. Okay. On the other hand, if this were just a protocol that you invented and you and your friends were going to do, and you say, okay, here's where you need to connect. Well, there's no router in the world that's going to have understood that, so it will go out like that. And what will you have to do? Well, you will either have to live with the fact that you're not going to be able to make connections back to you, or you're going to have to go in and manually add a rule or get UPnP involved to add the rule for you. Okay. So, but now you'll notice that the application layer is having to become aware of the fact that, well, I'm talking about if you're writing the program now, is having to become aware of the fact that it is in fact behind a firewall and is being natted. So somehow that doesn't seem quite right either. That you're saying, oh, you know, my program that I'm writing, I have to figure out whether I'm behind a firewall, and if I'm behind a firewall, then I have to get my firewall to add these rules and stuff like that. But if I'm not behind a firewall, or if I have a routable IP address, then I don't need to do that. So things are getting kind of messy and sort of breaking down. Okay. Yep.
So you're saying that you can't be writing IP address in the application layer except for certain exceptions like FTP protocol or FTP?
Yeah, so that's basically what I'm saying, yeah, is that it actually depends upon your router, right? But, but that's right. If you have any information about your IP address or your port number that you might want someone to use or contact you on, and so they have to get back to you, then you're kind of out of luck. Unless you want to go through all these other steps.
Why? Oh, okay.
So I mean, you might, so how did FTP actually solve this? FTP actually solved this by introducing some new commands and said, well, you know what? Instead of the server connecting back to who wants the data, why don't we have the guy who has the data connect to the server, tell him it's connected, and then send the command and let it come back. Okay, so that's how they got around it, or partly got around it, I should say. But it doesn't work now is, well, what happens if that server is itself behind a natting firewall? It kind of starts to unravel. So the types of applications that you can write and that start to be restricted. Right? There's certain patterns then that are precluded from what you write. Any other questions? Yep.
Why can't it just send it? Is it just,
Sorry?
Is it just a protocol?
Well, why doesn't it, what you mean, why doesn't it send it back on the wire that it came on? Well, first, to be honest, I don't know. But initially when they established this protocol, it was quite generic. So this is how it's normally used. But the protocol is actually more generic than that, in that you'll never believe this part. Well, maybe you will. That you can introduce a third machine into here, like this, and you can tell this guy here that you want the data to be transferred to that machine as opposed to you. And so when you do that, so what do you do? Well, this guy says, OK, it talks to this machine and tells it open up a port. And then it tells this machine just connect to this IP address on this port, and it just goes there. So the original protocol, or, well, the protocol is, in some sense, much more general than how we actually tend to use it. And so that's why you sort of get into that bind. But if you didn't have this generality, then you probably could get away with doing something like that, which is what HTTP does.
Is there a corollary protocol that does what FTP does but doesn't do it this way? Doesn't do its job? It seems kind of like.
Well, I mean, HTTP does, right?
Right.
Yeah.
So it seems like it's superfluous. It's like a extra.
Sorry? It seems like they're.
Superfluous. It's like it's.
Oh, so this, OK, so first of all, the comment was made, this seems like a superfluous protocol, it's not needed.
Yeah.
OK, so you have to understand that this actually predates HTTP.
It's really old.
I guess that's one way of putting it, yeah. I know that it existed at least in 1985.
Oh.
And HTTP and stuff like that didn't come about till the 90s. So, and then HTTP is sort of never designed to transfer files in this fashion, but people, of course, have figured out firewall issues, right? Because, oh, sorry, not firewall issue. This is natting, but it does go to the firewall issue, which is the next topic that's up. Okay, so let me just sort of go on to that topic. Okay, so just a quick notion about firewalls, and this notion that in addition, so firewalls fit in kind of nicely here because they're at this particular point where what you can do is you can say, okay, well, what traffic is allowed into my machine? And this is independent of whether you're natting or not. But now that you understand how natting works, you could sort of say, okay, well, we could add different types of rules. So a firewall, in some sense, is a rule that are rules or non-rules that are out there that say, okay, the default thing is to send the stuff off into space. That's one way you can view it as. It's a a natting firewall that, or sorry, a natting router that if it doesn't have a rule, sends it off into space. And so if you want something to come through, you have to add the rules. So this is sort of the general idea then, is that you have a firewall there, and you establish rules that say things about what's allowed to come in. So you might say, for example, in the department, or one of the machines that I have set up in the department, it will not accept traffic from any machines that are outside of the department network or my home machine. If it comes from any place else, it just ignores it. It just says, oh. And how does it do that? Well, it looks at the source IP address. Right? And if the source IP address doesn't match the list of IP addresses that I say it's OK, it just gets dropped. You can also do it by protocol type as well. So you can say any IP address is allowed, but I'm only interested in it if it's on port 22, which is SSH.
You said you have a firewall set up that looks at what IP address is for the source. But what if your IP address changes?
Oh, if your IP address changes, then you're out of luck. Okay, so yeah, so my IP address doesn't change at home. Well, maybe it does, I don't know, but it doesn't change very often. So, yeah.
What if I like SSH into one of the UBC cpsc computers and then try to connect? Would that work from my like home?
Sorry? Connect to UBC CS.
So what if I connected to like SSH into one of the UBC CS undergrad accounts?
Yeah.
And then tried to connect to that? Would that work or not?
I'm not sure. OK, let me draw a picture to make sure I understand what scenario you're talking about. So we have a firewall here. You have a machine here. And so this is the area that you want to protect, right? Okay. And so you're saying, OK, I'm going to connect through here to here. And now what do you want to do?
And then I connect to your computer that's the one that you set up.
Oh, that my computer? Yeah. Then you'd have to go from that. Say that was my computer. Yeah. Yeah. That would work. Yep.
So is that what you do, remote desktop to like a machine when your home IP changes, and you can change it that way?
That. Yes. So that's one thing you can. Yeah. So that would be one way to address the thing, is that if your home IP address were changing, so you could go to like these machines that allow basically anyone in on SSH, and well, assuming they have the proper credentials, and then you go in onto your machine and change it. I'm always a little bit reluctant to do that because I'm always noted for having fat thumbs and things like that, and I inevitably make a typo, and now the machine that I was able to get in on from this way, going through this extra hop, I now have blocked it, and I can't get from home, nor can I get from this one, and now I'm completely blocked out. So I tend to do these things when I'm at school, so that if I do screw it up, I'm sitting at the machine that I can actually undo the mess that I've created. So, because the inconvenience of not being able to get to the machine is much more than just having this extra hop for a day or two while I have to figure that out. So here's some things that you can do with firewalls. You can block all the traffic. You can only permit certain traffic to go in. Again, those are done typically by administrators. Sometimes they can be automatically done based on some outgoing traffic patterns as well, just to say, OK, if you see this block of traffic going out, I know then some other traffic's going to be coming back in, so I need to allow that stuff to come in. A prime example of something like that might be, for example, DNS. So if you see DNS queries going out, you might say, OK, I need to open up the firewall so that DNS answers can come back in. And you might only do that for a very small amount of time, because you know that a DNS query that goes out, you should get an answer within a couple seconds. If you don't get an answer within a couple seconds, you can say, OK, well, I'm not going to get an answer. And so you might do something like that, where you'd open up for that, shut her back down again automatically, so that someone can't use that as a vector to attack you. Okay. And then you can do things like all traffic from a particular node, all traffic from a subnet, all traffic from a particular to a particular port or something like that. OK, so we'll stop there. that sort of finishes off routing. And so next class we'll go on. We have another digression first, UDP, which you will actually learn something about in tutorials this coming week. And we'll talk a bit about that in class, and then on to DNS.
It's all. And then there's do work. I mean, if you want, I'll have a system. You got another reserve for got the information.